Hi everyone, today we are going to look at how a API gateway securely authenticates and authorizes requests using OAuth2 JWT Keycloak and RBAC, and how all of this fits together into a scalable multi-tenant distributed system. First, we have the client layer, which contains components like mobile apps, web apps, and third party API clients. Here we have the initial data state where the client has no token. It may have just user credentials like username and password, or is ready to initiate an SSO login. It cannot access any protected API yet. The process here is that a user opens a mobile or web app and clicks sign in. The app redirects to the identity provider Keycloak to begin authentication. The impact here is that this flow externalizes identity management to a centralized service. It supports both human users and service to service accounts. Security risks like credential theft are mitigated via standard OAuth2 mechanisms. Then we have Keycloak here, which is the authentication service. And here the role of the Keycloak is to act as the central identity provider. It supports OAuth2, OpenID Connect, OIDC, SAML, SSO such as LDAP, Google, etc. The data state here is after login. On successful login, Keycloak issues an access token, which is JWT, that contains identity and access claims, and a refresh token, which is used to get a new access token without logging in again, and optionally an ID token for OpenID Connect. The claims inside JWT consist of data fields that describe who the user is, what they can do, and how long their access is valid. So it has a sub, which is a subject. This is a unique user ID, the subject of the token. The sub claim identifies who the token is for. It's usually the user's UUID or database ID. This helps us track user actions without exposing usernames or emails. And then we have email, the authenticated user's email address. We include the user's email as a human readable identity field. It's useful for logs, user profile resolution, and some UI personalization. Then we have a list of user roles assigned to this identity, and this tells us what the user is allowed to do. For example, admin, logistics user, or viewer. Our RBAC engine uses this claim to decide whether the user can access a given API. Then we have tenant ID and the organization or the customer, the user belongs to in a multi-tenant system. So in a multi-tenant environments like SaaS platforms, tenant ID tells us which company the user belongs to, and like Apple, Walmart, or Target, and this ensures that a user from one company cannot access data from another. Then we have scope. Scopes are like permission buckets. It tells us what permissions or API access scopes the token grants. A token might have read, orders, write, shipments, etc., defining what APIs this token is allowed to call. Then we have EXP, which is a timestamp when the token will expire. This ensures the tokens can't be used forever. Once EXP time is passed, the token becomes invalid and the user must re-authenticate or use a refresh token. Think of JWT like a digital passport. These fields are stamps in the passport that say who you are, what countries you're allowed into, and when your visa expires. These claims are signed and encoded. We trust the data only if the signature is valid and it was issued by a trusted authority like Keycloak. So the process here in summary is that the token is issued and returned to the client, and the client stores the token securely and attaches it to all future API calls as a bearer token. The impact is that this design allows stateless authentication and tokens can be verified locally without querying Keycloak again. Then we have the client to API gateway. The client sends the JWT to the API gateway. The data state is that the client now has a valid JWT. It includes the user's identity, roles, and access scope. And the process here is that the client sends an HTTP request to the API gateway, example get/orders. The JWT is attached in the authorization header like authorization, bearer, and so the impact here is that the API gateway becomes the central point for policy enforcement. Microservices don't need to worry about decoding or validating tokens. And then we have JWT validation at the API gateway. The process here is that the API gateway passes the token. It checks, is the signature valid, is the token expired, is the audience correct, is the user trusted. These checks are performed locally using the public key from Keycloak. And the data state here is that after validation, the token is considered trusted. The user now includes decoded identity claims. The impact here is that it's super fast, no round trips to Keycloak, and it reduces latency and load on your IDP. Then we have RBAC engine here. The process here is that the API gateway passes token claims, example, role, tenant, and scope to the RBAC engine. It evaluates, does this user have access to this API? Is this user from the correct tenant? Is this user allowed to perform the requested action? Example, delete, get. This logic can be inline in the gateway or delegated to Open Policy Agent, OPA, or a similar policy as code engine. The data state here is that the request is now enriched with contextual access decisions. User role can be logistic user, and tenant, we can define the tenant, and permissions like read orders, create shipments. Impact, the impact is it enables fine-grained access control and prevents privilege escalation and protects sensitive endpoints. Then we have an optional token introspection. The process here is that in some systems, tokens are opaque and they're not JWTs. In those cases, the API gateway will call post/introspect to Keycloak, passing the token for validation. The data state here is that the token is evaluated for active, if it's active, true or false, and client ID, scope, username. The impact here is that it allows central revocation and short-lived tokens, slightly higher latency but necessary for high security use cases. Then we forward to the protected then we have forwarding to the protected microservices. So the process here is that if the token is valid and access is allowed, the API gateway routes the request to the appropriate microservice. Like example, get/adders is routed to order service, and post/users is routed to user service. The gateway may attach headers like X, user ID, 123, X, roles, logistic user, X, tenant ID, Walmart. The data state here is that the request now carries trusted user context. Microservices can use this for authorization or auditing if needed. The impact here is that it keeps microservices simple and focused, and it centralizes all identity related logic in one place. Then we have response flow back to the client, and here the microservice returns a response, which is a JSON payload with shipment status. The API gateway forwards the response, logs activity, and optionally applies PII masking or response shaping. The data state here is that the client receives the expected response securely. Logs are created with identity context for auditing. The impact here is that it provides full observability and traceability. It ensures consistent experience across all APIs. And we have security features at every step. All traffic is encrypted, HTTPS only, and we have JWT signer and expiry validation, and we have MTLS between services. This is optional but ideal. We have rate limiting and abuse protection at gateway, and custom Keycloak realms per tenant, and policy based access control using RBAC OPA. So my learnings here are that JWTs are fast, but we must be careful with claim validation. RBAC is not static. It aligns with business roles and update often. Caching Keycloak public keys save time but must be refreshed safely. Centralizing logs at the gateway helps trace token misuse and abuse. Policy as code makes access rules easier to audit and maintain. This architecture gives us a secure, scalable, and multi-tenant-ready API platform. By externalizing identity to Keycloak and standardizing token validation and access control at the API gateway, we simplify our microservices while ensuring consistent, auditable, and efficient security across the board.